Factoring quadratic expressions. Factoring is when we rewrite an expression as a product of its factors. So, for example 1, if you look at a problem like this, you would naturally do the distributive property. So we would multiply the 2x times x to get x squared, and the 2x times 3 to get 6x. Factoring would be the distributive property in reverse. So instead of going this way, we would start off with 2x squared plus 6x, and then our answer would be 2x times x plus 3 in parentheses. It's also FOIL in reverse. And remember, FOIL stands for multiplying the first terms, multiplying the outer terms, the inner terms, and then the last terms. And then that combines for your final answer, simplified. So factoring would be going from this answer to what our original was. So we would start off with 2x squared minus 5x minus 3, and then our final answer would be x minus 3 in parentheses times 2x plus 1 in parentheses. We're going to go through a few different methods on how to factor. The first is factoring by the GCF. You have to do this first regardless of what type of polynomial you have. So first you're going to consider all the terms in the polynomial, and you have to find the GCF for all the terms, for the numbers and the variables. So you're looking for the greatest common factor. For the numbers you have 5, 25, and 15. All of those are divisible by 5. For the variables you have x cubed, x squared, and x to the first. So all of them have at least one x, and at most one x in common. So what you're going to do after you find the GCF is we need to divide each term by that GCF. So I'm going to divide this by 5x, this one by 5x, and this one by 5x. After that, we're going to divide each term through, so let's simplify what we can. 5 divided by 5 is 1. X cubed divided by x, we're going to be left with x squared. 25 divided by 5 is a positive 5. X squared divided by x, we're left with x. And then a negative 15 divided by 5 is negative 3. X divided by x, that cancels out. So after you've divided through, you want to double check and make sure that there's nothing else that any of the terms have in common other than 1 that you can divide out. Once you've done that, you want to write your final answer, and this is how you're going to write it. The GCF on the outside, which was our 5x, and then in parentheses, all the divided terms. So x squared plus 5x minus 3. And there's your final answer. If you think you've got the hang of it, I want you to pause, try this example, and then come check back with me to see if you got it right. If not, stay with me and we'll walk through this together. So our first step is to find the GCF. So we want to look at what is the greatest factor that they each have in common. 3, 12, and 3 have a GCF of 3. X to the fourth, x to the third, and x squared have an x squared as their greatest x term in common. So then we want to go through and divide each term by 3x squared. And then let's go ahead and simplify this. 3 divided by 3 cancels. X to the fourth divided by x squared is x squared. Negative 12 divided by 3 is negative 4. X cubed divided by x squared is x. 3 cancels out, and x squared cancels out. So I need you to be careful. When that last term cancels out completely, this is not 0. This simplifies to 1. So when we write our final answer, we're going to have 3x squared times x squared minus 4x plus 1. One way that you'll always be able to check to see if you factored correctly is if you take your answer, if you distribute your GCF and multiply, your answer should be the original problem that you started with. We're going to have to factor by grouping when you have 4 terms. So first, consider all the terms in the polynomial. Make sure there's nothing you can combine. And then 2, separate them into 2 groups. So we're going to split it right down the middle here. Next, we want to find the GCF of each group of terms. So in the first group, we want to find the GCF. 2 and 6 have a GCF of 2. X cubed and x squared have a GCF of x squared. Over here, 3 and 9 have a GCF of 3, and then 3 has an x term, but this one doesn't, so our GCF is just 3. Then we want to divide each group of terms by the GCF. So here I'm going to divide this by 2x squared and this one by 2x squared. Over here I'll divide by 3 and divide by 3. And then let's go ahead and simplify. 2 cancel out. X cubed divided by x squared is x, minus 6 divided by 2 is 3. X squared divided by x squared, that cancels. And then on the other side, 3 divided by 3 cancels, so we have an x, a positive x, and a negative 9 divided by 3 is negative 3. If you chose the correct GCFs and you divided carefully, you should have that what's left over from each group is the same on both sides. When that happens, you're going to write your final answer. In the first set of parentheses, you need to put your two GCFs, the 2x squared and the positive 3. And in the other parenthesis, you're going to put the terms that you got after you divided. That should be the same on both sides. And this is your final answer. And again, if you want to double check to make sure you got it right, just go ahead and FOIL this, and then you should get the original problem that you started with. Again, if you feel like you got the hang of it, I want you to pause and try this on your own and check back with me. If you need another look, stay with me and we'll walk through this step by step. So our first step is to split our factors in half, and then we're going to find the GCF of each side. Here on the left side, 10 and 20 have a GCF of 10. X cubed and x squared have a GCF of x squared. On the right side, when you look at this, this is not allowed to be negative. We want our very first term to be positive, so what we need to do is factor out a negative. So when you see 2 and 4, the GCF is 2, but I want to factor out this negative right here. So we're going to factor out a negative 2. And then we don't have an x term over here, so negative 2 is our GCF. Then we're going to go and divide each term by its GCF. 10x squared and 10x squared. And on this side, divide by negative 2 and negative 2. And then let's go ahead and simplify. 10s cancel out, and we're left with x minus 2, and the x squareds cancel out. And on the other side, the negative 2's will cancel, so we're left with x. 4 divided by negative 2 is negative 2. We did end up with the same thing on both sides, which is good, so we can go ahead and write our final answer. In the first parentheses, the two GCFs, 10x squared minus 2, and in the second parentheses, that common term that we found once we divided through. Now we want to factor trinomials in the form ax squared plus bx plus c, and specifically when a is equal to 1. First, we want to find the factors of c. So we're going to find the factors of 12. We have 12 and 1, 6 and 2, and 3 and 4. Next, you need to determine which factors are going to add up to b. So which ones will add up to 8? We have 6 and 2. If they need to multiply to positive 12 but add up to negative 8, that means that the 6 and the 2 both have to be negative. So remember, after you find your factors, you want to take into account what signs they are, whether they have to be positive or negative, and which ones. Then we're going to take these and we need to write our final answer. The way we're going to do that is you set up your two parentheses. You're always going to have x in the beginning of each set, and then you're going to put your terms in here. Negative 6, negative 2, and that's it. And again, if you want to double check to make sure you did it correctly, just FOIL this, and then you should end up with our original problem. If you think you got the hang of that, I want you to press pause, Try this on your own and check back with me. Otherwise, stay with me and we'll walk through it together. So first we need to find the factors of C. So the factors of 18, we have 18 and 1, 9 and 2, 6 and 3, and I think that's it. So we want to see which terms are going to add up to 3. Now none of these are going to add up to 3 as they are, but when you look carefully, this is a negative 18. If two numbers are going to multiply to get a negative answer, that means that one of those numbers has to be negative. So remember, one of these numbers is going to be negative, so which pair of factors, with one being negative, will add up to positive 3? So if we make this 3 negative, 6 minus 3 will give us 3. So this is our set of factors. Then we can go ahead and write our answer. So we have x in the beginning of both, then we have a positive 6 and a negative 3. And here is your factored polynomial. Now I'm going to show you two different methods of factoring trinomials when a is not equal to 1. The first is by grouping. So our first step is to multiply a times c. So we're going to multiply this and we get 30. So you want to find the factors of 30. We have 30 and 1, 10 and 3, 5 and 6, and 2 and 15. So then you have to ask yourself which ones are going to add up to negative 7. So again, because this is negative 5, one of the numbers needs to be negative. So if we take negative 10 plus 3, that's going to give us our negative 7. So we want to replace our bx, that middle term, with these two factors. So we're going to take 6x squared minus 10x plus 3x minus 5. Then from here, we're going to do what we did before, factoring by grouping. Split this in half, find a GCF here. We have 2x, and then find a GCF over here, which is actually 1, because 3 and 5 don't have anything in common, and 5 doesn't have an x term. So then we want to go through and divide by the GCF on each side. And then we're going to be left with 3x minus 5 on the left side, 3x minus 5 on the right side. So even though our GCF was 1, we still ended up with the same answer on both sides. So then we can write our final answer. So we have 2x plus 1 are GCFs in one set of parentheses, and then our common factors, 3x minus 5 in the other set. And here's your factored polynomial. So again, pause and try this on your own if you can't, otherwise just stay with me. So our first step is to multiply a times c. 3 times 4 is going to give us 12, and let's find the factors. 12 and 1, 3 and 4, 6 and 2. So ask yourself, which factors are going to add up to negative 13? We have 12 and 1, but both of them would have to be negative. So we're going to replace that middle term, 3x squared minus 12x minus 1x plus 4. And then we can go ahead and factor by grouping. Split down the middle, find the GCF of each side. On the left side, we have 3x, and on the right side, again, we don't have anything in common, but when you see this negative right on the other side of the split, you need to factor out that negative. So we're going to divide each term by its GCF, and over here we're going to divide by negative 1, so that when we simplify, we have x minus 4 on the left side, and then we're going to have x minus 4 on the right side. Since these are the same, we can write our final answer, our GCFs in one set of parentheses, and that common factor in the other.